I'm a game changer. I'm a risk taker.
Our team members are Ryan Montal and 𝗃𝗧𝗨. We are from Anderson Secondary School, Singapore. We have been in Robotics Club for 2 and 3 years respectively, and this is our first time taking part in the RoboCup competition. We are participating in the CoSpace Rescue Competition U19 League. Our main task is to collect as many points as we can in the allocated time. Some problems we encountered were that the robot went out of the map when avoiding a physical object, and the robot spun in circles after we added a new feature. We tried to increase our score by increasing the likelihood that the robot will obtain a gem that will lead to the completion of a 𝗈𝙗𝙨 𝗵𝗂𝗂. Our program was successful and we were able to get quite a good number of points. However, the program was inconsistent and can be improved. The challenge task was to obtain as many points as you can without falling into traps and within the allocated time. The challenge task can be simplified into multiple mini-tasks, such as how to navigate to deposit zones, how to avoid running into obstacles, and how to avoid falling into traps. When all these mini-tasks are complete, the overall mission can be completed as the robot efficiently carries out all the functions that it needs to do. There are 3 main strategies that we used. The first strategy we used is for the robot to go to the double point zone at the start of the round and after every 2 deposits. The second strategy we used is for the robot to navigate to the deposit zone after it has collected 6 gems. The third strategy we used is for the robot to avoid obstacles and avoid going out the map. The tools we use are Visual Studio Code and the debug screen in the CoSpace Rescue software. Our first strategy is for the robot to go to the double point zone at the start of the round and after every 2 deposits. The robot will not leave the double point zone until it collects 2 red and 2 cyan gems. After 2 red and 2 cyan gems are collected, the robot will exit the double point zone and will not enter again unless there is a super gem inside. Sometimes there are not 2 red and 2 cyan gems in the double point zone, and the robot was stuck there forever. To decrease the likelihood of this happening, the robot enters the double point zone every 2 deposits instead of every deposit to allow for time for the gems to respawn. Using trigonometry and knowledge about the horizontal and vertical distance between the robot and the deposit zone, we can find out the angle that the robot needs to turn to go to the deposit zone. We also account for each of the 4 quadrants that the deposit zone may be in. To avoid the robot getting stuck, we allowed the robot to run as usual for 1.5 seconds after detecting an obstacle instead of turning to the deposit zone. Our third strategy is for the robot to avoid obstacles and avoid exiting the map. We ran into the problem of the robot exiting the map as it avoids a physical obstacle instead. Hence, we designated the edges of the map as walls in front, on the left, or on the right of the robot, depending on the compass direction. Swamplands and physical obstacles were also designated as walls. All 3 of these obstacles are treated the same and avoided under the same system. One problem we faced was that the robot was stuck in a loop of going around in circles after we added a new feature. We could hence conclude that the problem was caused by said feature. We used the debug screen and observed the number of the curl action and found that the curl action was always the one used by the new feature. Hence, we changed the order of the code so that the new feature was below the one it was interfering with, which fixed the code. In conclusion, we are happy with the result as we obtained the highest score of over 1200. If we were to solve the same challenge again, we would navigate to super gems to increase our score. We would also program the robot to avoid the top left corner of the map, as it is hard for a robot to escape from it. Through this competition, we have learned to use C code. We have also gained an insight into how programming and mathematics may be used in our day-to-day lives. The most important point that we'd like to share is to first break the map down into simpler and smaller zones that each have a unique purpose. For example, you may want to enter one zone as a higher amount of black gems, or you may avoid another zone as it's hard for a robot to exit that zone. Thank you for listening to our presentation.